Hi folks, this is Team 67 and our project is human activity detection. So there are two ways to detect human activity. One is to put the sensors on hand or on the legs or on the gait, like how Professor taught us in the lectures. But that is too cumbersome and it's very uncomfortable. The other way is to use surveillance videos or images and detect what the person is doing. So which was the second option, which is more prevalent these days. We are basically recognizing what the person is doing from a surveillance video or in YouTube video and so on. So for this project, we used UCF 101 data set, which has 101 action categories, action labels like applying lipstick, walking, playing basketball, and so on. This data set had 13,320 videos and 101 action categories. Uh, For pre-processing, we took the videos and then we extracted frames from the videos and then we resized and normalized we resized the frames to 224 into 224 pixels and then normalized the pixel values to have a better data. So for the baseline, we used a pre-trained ImageNet model. So ImageNet model is used to extract features from still images, and then we whatever the features that ImageNet had calculated, we tried to feed it into an LSTM model that we created separately. So the model which we had created had an LSTM model with 1024 units and zero point 0.5 dropout. And similarly, the next layer has a dense layer with 256 neurons, ReLU activation, and zero point 0.5 dropout. The third layer had 512 neurons, ReLU activation, and zero point 0.5 dropout. The final output layer had 101 neurons corresponding to the number of action labels, the output labels we had, and it had softmax activation function. So we divided our data into two sets. One is training validation set, and the other one is testing set. Inside the training validation set, we divide the data. I mean, we had put 80% of the data as a training data, and 20% as validation data. Uh, we trained our model for 50 epochs. We used Adam Optimizer and top 5 categorical laws. So top 5 categorical laws by default takes top k categorical laws by default takes top 5 categorical laws, and then it's nothing but basically what is the with what amount of accuracy you're predicting top 5 possible action labels. So if someone is walking, the top 5 action labels would be walking, running, walking soft, right? So top k categorical laws detects with what accuracy our model is calculating or predicting the top action labels. So, so our baseline model did not do as good as what we expected. So we had an accuracy of 63% and categorical accuracy of 97%. Validation, the accuracy was way down to 10% and a categorical accuracy of 56%. And tested also did bad. We had 77% accuracy and 41% categorical accuracy. So we reached out to the professor, and then he said, "This is an appropriate uh, training and testing results, uh, depending that we are creating the new model." And he gave us pointers, and then we transferred from ImageNet to Inception V3 model. Inception V3 model is basically good for extracting features from the frames that are derived from videos. So it has larger kernels, and then it has it automatically detects which features from the previous frame could be used or not. So that is the reason we went to the Inception V3 model. And then the model which we used, we edited it as well. So we updated the LSTM model to contain 2048 units, and we removed the dense layer with 256 neurons in between, and then the next layer we made our model to have uh, in such a way that there is a LSTM model and the dense layer with 512 neurons, relay activation zero point 0.5 dropout, and the final output layer with 101 units with softmax function. This is basically the architecture of Inception V3 pre-trained model that we used. And finally, our final model uh, uh, gave us good results. So we had a training accuracy of 85%, categorical accuracy of 98%. For the validation, we had an accuracy of 75% and 93 categorical accuracy of 93%. For the test set, we got an accuracy of 66% and category accuracy of 86%. We had a confusion matrix, but it is too big to fit into a PPT. So we are planning to create the histograms and pie charts for it to be more visible. That we'll probably submit this Friday. So yeah, this is our project. Hope you like that. Thank you.